Hi everyone. My name is Olena Borzenko. I'm coding consultant at Xibia, and today I'm very happy to be back to Azure Cosmos DB conference. This was one of my very first few conferences when I was just starting to be a public speaker. And today I have for you a session called Turning Data into Generative Chaos. Before we will dive in, I want to give a little introduction about the session in general, why I'm doing this, why I'm talking about the art and generative art, and all the other stuff. So um, I'm also Microsoft MVP, and my technology field is Azure Cosmos DB. So I worked with this for quite some years, and I really happy that I can integrate it not only at my clients and at my work, but also with my hobbies. So today's session is about me combining my hobby with my daily work, with my actual professional job. So I always loved making art, but I never get a chance to go to the art school. Instead, I ended up studying applied physics in a university. So after that, I became a self-taught software developer, and I didn't have enough time to actually do art or explore some creative and artistic things. So after working and getting myself pretty skilled in software development, I decided that I'm not ready to give up my dream and idea of becoming an artist, and I want to explore it using my professional skills. So I started building a tool to bring my hobby into my work. But before I started doing this, I had quite a journey. The last year, I had a chance to work with the CNC machine, and this which you can see in the picture. CNC machine is typically used for wood carving, or you can have the same principle for laser cutters. But you can also put a pen in there and use it as a plotter machine. What you can see on the picture is one of my first art pieces that I did. I had to learn quite some programs that I had no knowledge in and no skills, like 3D Max and Aspire and SketchUp to do an actual 3D visualization and then extracting the 2D image for the future printing. And it was quite some struggle for me, but I kept experimenting and trying different techniques and different colors. So this one of my other pieces, and it's kind of messy, but I did enjoy a lot the process of creating it and using different techniques. I started introducing the brush strokes and also using some acrylic paint, all this stuff. I kept working on this because it kind of was giving me a little vibe of combining art, creativity, and also math and technology. So the next pieces that I did was actually a diptych. So it's two related art pieces. And as you can see, they are related by the concept and the brushstroke. And the only thing that is different is just the 2D graphics and the color. And this was a breaking point for me because on the picture from the right side, well, from my left side, you can see this red and black brushstrokes. And that's what I really liked, the intersection of brushstrokes with the 2D wireframe graphics. So I started exploring it more and more, and I started working on more art pieces. And this is the results that I got, and I was really in love with them, the way how they look, and the different colors and the combinations and shapes. I even made a present to my mom. So this on the white background, this was a present for my mom. She had a birthday on 27th of February, and I was standing at her place. And the last picture was one of my very experimental pieces. It actually, in real life, also have different structures. If you turn it around, you will see also nice textures. You probably can see also on my background, there's hanging another piece, which is not displayed on a presentation, but also one of my recent ones. So the thing is, I really enjoyed doing this, and I had an opportunity to do some 3D graphics visualization, improve my skills, but also use brushes and acrylic paint and do some actual creative work. However, I don't have that much time because each of the pieces takes at least 12 to 24 hours because it's a layering paint and it's a lot of work to do. I didn't have time to put even more time in improving my skills, but I wanted to do more things like that. So I decided that I can use my professional skills to and combine it with my creativity and do some art pieces together. So I started exploring algorithmic art, parametric art, and generative art. Before saying how I combine this, how I actually used it in my project, I want to explain a little bit difference between those things. So first of all, algorithmic art, you can use different formulas. It's not necessarily have to be one formula, but if you take those two lines and you iterate through them in a loop, and you provide R parameter and angle, as a result, you will have with a consistent logic. As a result, you will have a fully deterministic output. So that's what's called algorithmic art. Uh, so the math here is procedural and not necessarily bound to a single formula, but the outcome will be always the same no matter how many times you run the script. And this is the example. The previous two formulas, I used P5GS to create this visualization, and this is the output. It's very simple, but already look quite nice. However, for complicated shapes like torus node, the one that you saw before on the previous slides, you need a bit more than just two lines of code and two formulas. So parametric art, parametric art is based on the parametric equations. And parametric equations is exactly what you use when you want to create a 2D or 3D graphics of a torus node. So this based on functions where the shape is driven by one or more parameters. And you can see on the screen, this is exactly the formula that I will be using in my project, in my implementation for creating the torus node. The thing is, what's the difference between parametric art and algorithmic art is that you're plotting points as a function of time. As you can see, x has dependency from time, from t, the same for y, and the same for z. So what it means, the essence of this parametric art is that shapes defined by formulas, but they are being transformed by the parameters. And the next one, so this is the examples of the parametric equations that I used for creating a very nice visuals. And it was for me an inspiration when I was creating my project. It was also an inspiration when I was just starting to do all those art pieces, because I do like symmetry and I do like the shapes of it. The next step here is generative art. So, of course, we know a lot about generative art, especially taking into account all those AI tools and modern technologies. We can generate picture using, for example, the DALL-E model, and this is going to be generative art. But that's not what I was interested in. I wanted to use parametric equations and algorithms and create generative art based on certain descriptions, rules, and logic. So what makes my art generative, or for example, the code that you can see on the screen, is a little randomization of parameters. So those 4 lines, they make result unpredictable. So every time when you will refresh the page, for example, or when you will re-render your code, there's going to be different shape, different result. It's going to be led by the formulas that you can see, but you will never be able to predict the outcome unless you're very good in math. So you set the rules and you let the system surprise you. And that was exactly what I wanted to achieve. I wanted a system, my project, to help me create more pieces that I will not be able to create myself, because I already have certain opinion on how to build things. And I will never choose certain parameters. I will never experiment in a way that can be experimented with code and generative art. So just a few words about the concept of the project. I wanted to take any user input data. I had a couple of iterations of this project, and in the first iteration, I thought that I can take environmental data, for example, data from IoT devices like temperature in the room or humidity in the room, and transform this data in a small, short art descriptions, and then use algorithms to generate small visualizations. I thought that could be a nice experiment, let's say. That was for my first iteration, and it didn't really go quite well because even if I wanted to generate something very simple, it was still quite hard to define which function and which algorithm to use in which case. So I decided, since I found for myself that I really like torus node shape, I decided to keep it very simple and very focused to one shape in my current application. So taking user input, in my case, I'm just providing short prompts. Like for example, I want to see a shape that looks like a flower, or the shape that looks like a star, maybe even mentioning the color scheme. And this will be actually more than enough. This user input, this input will be taken and sent to LLM with a specific prompt. Based on this information, the LLM will generate for me our description. It will be not very long, just 1 or 2 or 3 sentences. It's gonna give a bit more details about the final view of the art. So, for example, the shape that looked like a flower, it will just give more details of how it should be twisted, what colors should be used, and so on. And based on that information, I will be generating a torus node configuration, which is going to have a very strict JSON schema. It's really hard to achieve with LLMs because LLMs tend to hallucinate and make mistakes and give different outputs, but so far it was working quite well for me. And the last step is visualization of a torus node using P5.js. So that was the concept. And let's have a look a bit into more technical details. As I already said, there's going to be a user input, and I'm going to have a little React page. When I'm going to have an input field, a little button, and when I will be clicking on it, I'm going to be sending a request to my Generative Chaos API. It's going to be post request to generate our description. I also have AI project on Azure, and I have there 2 models. I have Dex3 large model for generating embeddings, and I have GPT-4 Omni for completion, for generating my art descriptions and creating my torus node configuration. So I will send a request to generate embeddings, and after this, I will create a prompt and I will send it to GPT-4 to get the description. Generate design, generate the description of my design and actual configuration. I will save it, the embeddings and the design itself, I will save it to Azure Cosmos DB, and then I will give back to my UI torus configuration. I'm saving embeddings and I'm generating them because I want to be able to find similar items by user description. So for example, I can be experimenting with the flower-like shape and I want to find similar items to this shape. So I will be using vector search, providing a sort of similarity score, and I will be getting similar art so I can then choose the one that I like the most. And this is going to be the last step. So let's do a demo and actually have a look on how all this works. So first of all, I will walk you really quickly through actual code and show you what I implemented. So there is my Generative Chaos API. I try to keep it as simple as possible, having just one project with the controller and my services and some business logic. So I have generate design, get designs page, and search similar designs. Just 3 endpoints. The main endpoint is generate design async, and if you go there, we can see that we are doing exactly what I mentioned on what I showed on the slide. We are generating embeddings, and then we're generating design configuration. I'm using Semantic Kernel for this, and if you go inside, we will see that this is very straightforward. Getting required service, text embedding generation service, get embeddings, returned back. I'm not using those embeddings to generate my configuration. I'm going to be using them to save them in database for later for finding similar items. Generate design configuration is a little bit more complicated because it uses 2 different prompts. If we will have a look, so those 2 lines generate our description, and those 2 lines, they generate an actual torus node configuration. If you will go have a look on the prompt itself, you can see the first prompt is quite simple. So you are an assistant that transform creative art prompts into vivid, artistic visual descriptions. So I'm providing some information, some context of how I want this description to be generated, how long should it be, so 1-3 sentences, and I'm also providing the input. So far, it was generating quite good results, but I'm not sure if this will be enough for me, because later on, I want to use those descriptions as an art concept. And for this, I will need to take a little bit more. But for now, it was doing pretty good job. The second prompt that you can see is quite long actually, but it also does quite a good job. So far, I didn't have a single time that I got output not as I need. So the prompt saying that you are an assistant that transform artistic visual description in a torus node configuration, and there is a certain rules of how this configuration should be created. So the thing is, this is the schema, and I need very strict output. I need it to be exactly in the schema. But besides this is not the most complicated part of it. The most complicated part is that all those properties, they are related to each other. So if you said, as you can see, for example, P and Q is a very base of generating torus node, because if they are the same numbers, or they are not prime numbers, the result will be not very pleasing. It's not going to be very nice. So I'm providing all those rules and some additional rules as well. As you can see, P and Q must be prime numbers, not equal, and P have to be less than Q. So I can add more and more rules to this, but I wanted to give a little bit of freedom to LLM, and even if result is not very satisfying, it's still a good experiment. So this is how the second prompt looks like. And if you go back here, we can see that I'm generating this art configuration, and I'm just returning it back. Yeah, as you can see here. I'm overrunning a few properties here because I wanted to do a bit more experiments and have a little bit more control over this, but yeah, it's not, I can remove those 2 lines and results going to be just a bit more chaotic and unpredictable. So after this, I'm saving the result in Cosmos DB, and I'm returning the torus node configuration to the AI. When I want to find similar items, what I do is I'm using the same user input. So I'm sending those 2 requests simultaneously, one to generate design and the second one to find similar items. And what I'm doing, the same thing. First, I'm generating embeddings because I don't have embeddings yet at this point saved already in database or something like this. I have only user input. Having those vectors, I'm just getting all similar items, well, not all of them, but just top 5, using the vector distance function with a similarity score, which is in my configuration, but it's now set to 0.75. If you want to have almost exact items, you need to increase the similarity score almost to 0.99. But for me, I wanted to get everything that looks like or reminds me of certain user input. So I lowered it to 0.75. Yeah, so I'm getting all the results and then I'm just transforming them to my DTO because I don't need vectors on my UI, so I'm excluding them and I'm receiving back only the torus node configuration and the user input. So this is basically this is the main logic. The last method that we have here is just getting all the items from the container, and I did it mostly for testing purposes. So yeah, I'm not using it that often. I'm gonna do a very quick walk through the UI. So this is the React application, and I'm using React with White. So I have 2 pages. One is a home page and one is a gallery page. As you can see here on the UI, I have a default configuration for torus node because I don't want to open the page and see nothing. And here I have a logic. So I'm calling my 2 endpoints to create a design and to get similar items based on the user input. And then I'm rendering the torus node configuration, the torus node shape. This file has all the logic and all the calculations, all the math with all the effects. And I spent, I think, most of the time building this project, I spent building this component. Uh, I basically reversed engineered 3D Max, and it was much more complicated than what I thought from the beginning. So the configuration file is quite big, and all those properties are manually, well, not manually, all those properties they implemented as a side effect for the torus node shape. So it's not going to be just a straight tube. It's going to have twists. It's going to have certain flat surfaces and lumps and all the other stuff. You will see the result now just in a couple of seconds, but the file is quite long. And if you ever feel interested in having a look on actual implementation, on the slides in a couple of minutes, you will see the QR code to the repository. And let's go now to the portal just for the second, because I want to show how I set up the Azure Cosmos DB. So I have my account created for NoSQL, and I have my database and container where I will be storing my designs. I also had to enable a feature, so vector search for NoSQL API. I enabled it because otherwise it will not be working, of course. And if you go to the container itself, you also will need to set up the container policy and indexing policy to make sure that you will be able to save embeddings and do the vector search on your data. So let's have a quick look at the items itself. So I already played a little bit with the application, and that's if we will have a look inside a file. So that's sorry. So that's how the torus node design looks like. We have the user input, we have a generated description that has a few sentences, and we have and we have the torus node configuration. So this is just serialized object because I cannot store an object as a vector data, so I had to make a string out of it. And then, of course, I have vectors that I'm using for similarity search. Let's have a look at the application itself. So this is how it looks like. This is pretty simple for now. This is just a simple grid as a gallery where I'm showing all the results that I have in a container. I'm hiding all the other torus nodes because for now, I don't have a pre-saved result. So each of those cells is actually P5.js code that is rendering the torus node. And I killed my browser a couple of times. So I decided to hide a few of them just to make sure that presentation will not fail. But if we click on this, we will see the visualization. And you can see the forms looks quite nice and interesting. And I can definitely use some of them to create art pieces later on. Okay, so, but let's have a look on how it's actually being generated. So, for example, this is just a default configuration that you saw, and I can say flower-like shape. And I think this is enough. I will click generate. Of course, it's taking a little bit of time because we have 2 requests to LLMs and then we're generating the embedding. But we get the result and we even get some related visuals. So the related visuals, as we can see, the flower-like shape with smooth lines. And this one looks actually much better than the actual outcome. I think I need to work a bit more on the colors. But this is basically how it works. So I can do more. Star shape that looks like a star. I'm not sure what's going to generate, and if I have more of those. Okay, so I have more related visuals. For some reason, I got the same result, so I guess that can happen, or something went wrong in my code. But we also get related visual that also shape that looks like a star. So we also can see that more items were added here. So it was just generated 2 times, very similar result. That's fine. So at this point, That's always the demo, and I will go back to my presentation. And here you go. There is a QR code to my repository if you want to have a closer look to the code itself, to the logic, and how it works. And thank you very much for your attention. Here is my Instagram because there I'm going to be posting more of my artworks, and also LinkedIn and Twitter. Please feel free to connect. And thank you very much for your attention.